Inductors and capacitors in DC circuits. Why does the LED glow? Introduction. Have you ever wondered why an LED behaves differently when connected to a DC source with an inductor versus a capacitor? In this video, we'll explore two simple circuits, one with an inductor and an LED, and another with a capacitor and an LED. You'll learn why the LED glows in the first circuit but not in the second. By the end, you'll understand the key differences between inductors and capacitors in DC circuits. Let's dive in. Chapter 1. The basics of inductors and capacitors. Before we dive into the circuits, let's quickly review what inductors and capacitors are. 1. Inductor. An inductor is a coil of wire that stores energy in a magnetic field when current flows through it. It resists changes in current, meaning it tries to maintain the current flow even when the circuit is turned off. 2. Capacitor. A capacitor stores energy in an electric field between two conductive plates separated by an insulator. It resists changes in voltage, meaning it tries to maintain the voltage across its plates even when the circuit is turned off. These behaviors make inductors and capacitors behave very differently in DC circuits. Chapter 2. Circuit 1. Inductor and LED in series with a DC source. Let's start with the first circuit, an inductor and an LED connected in series with a DC source like a battery. What happens? When you connect the circuit, the LED will glow. Why? 1. Initially, the inductor resists the change in current, but once the current stabilizes, it acts like a regular wire. 2. Since the inductor doesn't block DC current, the current flows through the circuit, powering the LED. 3. The LED glows because it receives the necessary current to emit light. In a DC circuit, an inductor behaves like a short circuit, a wire with no resistance once the current stabilizes. This allows the LED to glow. Chapter 3. Circuit 2. Capacitor and LED in series with a DC source. Now, let's look at the second circuit, a capacitor and an LED connected in series with a DC source. What happens? When you connect the circuit, the LED will not glow. Why? 1. A capacitor blocks DC current once it's fully charged. 2. When you first connect the circuit, the capacitor charges up quickly, allowing a brief current flow. 3. Once the capacitor is fully charged, it acts like an open circuit, a break in the circuit stopping the current flow. 4. Without current, the LED doesn't receive power and doesn't glow. In a DC circuit, a capacitor behaves like an open circuit after it's charged, preventing current from flowing through the LED. Chapter 4. Key differences between inductors and capacitors. The behavior of the two circuits highlights the key differences between inductors and capacitors. 1. Inductors. Allow DC current to flow once the current stabilizes. Resist changes in current. Act like a short circuit in steady-state DC circuits. 2. Capacitors. Block DC current once fully charged. Resist changes in voltage. Act like an open circuit in steady-state DC circuits. These differences explain why the LED glows with the inductor but not with the capacitor. Chapter 5. Real-world applications. Understanding how inductors and capacitors behave in DC circuits has many practical applications. 1. Inductors. Used in power supplies to smooth out current. Found in motors and transformers. Essential in radio frequency (RF) circuits. 2. Capacitors. Used in power supplies to smooth out voltage. Found in timing circuits and filters. Essential in energy storage systems. These components are fundamental to modern electronics and electrical engineering.